The age of the simple coder is officially over.
It's done.
Get ready for the Renaissance developer. AWS CTO Werner Vogels just delivered his final reinvent keynote, outlining 5 radical shifts every builder must make to survive and thrive in the age of autonomous AI agents.
And we're going to deep dive into what verification debt is.
And why it's probably the biggest threat to your code quality right now.
Welcome to this deep dive. Our mission today is really laser focus. We're extracting the core actionable intelligence about the future of software development.
And we've synthesized a huge stack of source material for this.
A massive amount. We've got keynote transcripts, technical sessions from reInvent 2025, deep research, all pulled together for you by Notebook LM.
And the goal here is to find the principles that won't change.
Exactly. Even as the tools are changing at what Vogels himself called an insane pace.
That insane pace is the real problem, isn't it?
It is.
It forces us right into that core, that existential question Vogels addressed, will AI make me obsolete?
The question everyone is asking.
And his answer wasn't some platitude. It was a qualified but really firm no.
But that qualification is everything.
It's everything. It's no, only if you evolve, if you stay static, the future is absolutely going to pass you by.
Precisely. The developer who refuses to evolve is the one who faces obsolescence. So this deep dive is all about understanding the shape of that evolution.
Because the game has fundamentally changed.
It really has.
So let's start with the central figure he introduced, this Renaissance developer.
Yeah.
I love this framing because it just instantly changes how you think about what we do. It's not just about typing syntax anymore.
No, and Vogels used this analogy of the 15th century Renaissance, and it's so apt.
Right.
That period wasn't just about, art flourishing. It was a convergence of art, science, technology, all driven by intense curiosity.
And accelerated by new tools.
Exactly, like the printing press. And our current moment with generative AI, it feels just as profound.
So the developer's role shifts from being, primarily a code writer to becoming a modern polymath.
A modern polymath. And if you think about that classic I-shaped developer...
Deep expertise in one thing.
Right, deep vertical expertise in, say, Java performance tuning. That's not enough anymore. The Renaissance developer needs to be T-shaped.
So you have that deep domain expertise.
Yeah.
But it's coupled with this incredibly broad knowledge across multiple disciplines.
And this is where the conversation sometimes gets stuck, because people hear polymath and they think they have to be an expert in everything.
That's unstressful.
Totally. But the real point is about connectivity. The breadth is what's crucial today, because the systems are so interconnected and the frontier moves so fast.
But let's pause on that, because that raises a really important question about scalability, doesn't it?
It does.
How can one person be expected to maintain deep expertise and also master things like the economics of system performance or post-quantum cryptography?
Right.
Isn't Vogels just demanding that developers become these perpetually stressed, underinformed generalists?
That's a brilliant challenge, and it hits on the key misconception. The Renaissance developer isn't necessarily writing the code for the post-quantum encryption.
The AI agent might be doing that.
The agent handles that, but the developer has to understand the implications of integrating it. You need the breadth of knowledge to ask the right questions.
Like, if I integrate this new crypto standard, what does that do to my latency at the 99th percentile?
What's the cost profile? Are there supply chain risks in this library I'm using?
So the AI handles how the coding, the implementation details, but the human has to master the why and the what if.
Precisely. That holistic systems-level view is what defines this new archetype. Without it, you're just integrating frontier tech blindly.
And that's a recipe for catastrophic failure.
Absolutely.
To get to that T-shaped mastery, Vogels laid out 3 foundational qualities. So let's start with the first one, which is the driver of the whole process: curiosity.
Curiosity is positioned as the essential survival mechanism. It's that relentless, almost childlike drive to ask why and what if.
It's what ensures you keep learning, which is just non-negotiable now.
It really is. Vogels reminded everyone that the tech landscape has always been in flux. Developers survived the shift from writing assembly to object-oriented programming.
And from command line editors like Ducey to fully integrated cloud IDEs.
Exactly. The Renaissance developer sees AI not as a threat, but as the next printing press, a tool that accelerates creation and forces you to learn faster.
So if you lack that fundamental curiosity, you stagnate.
Yeah.
And the tools just render your knowledge obsolete.
Yes. Stagnation is now a professional risk. Vogels was essentially arguing that the moment you stop asking, why is that system behaving that way, is the moment your value starts to depreciate.
And tied right into that deep curiosity is the second pillar, which requires a real mental leap. Thinking in systems.
Right.
This is about moving past your immediate code base or your one microservice and thinking about the whole complex environment.
This is where Vogels brought in that powerful analogy, the one about reintroducing wolves into Yellowstone Park.
Such a great example.
On the surface, you wouldn't connect wolves to rivers,
Not at all.
But the wolves changed the behavior of the elk, so the elk stopped overgrazing the riverbanks, which let the vegetation grow back, stabilizing the soil, and that eventually reduced erosion and changed the course of the rivers themselves.
That is a perfect illustration of a second-order effect.
It is. And in resilient software design, systems thinking is about anticipating those non-obvious cascading effects.
So if you change a dependency deep within one service to save a bit of cost.
What's the downstream impact on latency for a critical customer-facing API? Does a security patch in one library unintentionally create a thread deadlock in a completely unrelated system?
You can't manage that unintentional complexity in distributed systems without this mindset.
Impossible. Which is why Vogels insists on the third non-negotiable pillar, the human responsibility stake or ownership of quality.
This is the operational and ethical foundation.
And Vogels was crystal clear on this. AI is a fantastic co-pilot, but it is not a delegate. If an AI generates flawed, non-compliant, or insecure code, the human developer holds the full responsibility for shipping it.
The quote that stood out to me was, "The work is yours, not the tools. You build it, you own it."
That's the one.
If you accept the pull request generated by an AI agent, you just signed your name on the quality, the performance, and all the security implications.
And this requires professional pride. Real pride and operational excellence. It means owning the unseen systems, the clean deployment, the reliable rollbacks, the clear telemetry.
We're moving from a world where we spend maybe 80% of our time writing code to one where we spend 80% of our time validating and owning the system's integrity.
And if you ship garbage, even if an AI wrote it, you're the one getting woken up at 3 a.m. when that garbage breaks production.
That shift toward AI doing the heavy lifting brings us to the core of the value proposition here. A Boston Consulting Group consultant characterized it as AI removing toil and muck so humans can go off and make music.
It's a great way to put it. It's about automating the administrative tasks, the soul-crushing documentation updates, the boilerplate unit tests, the JIRA maintenance.
The things that developers universally despise.
If AI can take those tasks off your plate, your cognitive load is freed up to focus entirely on the high-value work. Design, validation, security review, and that system-level thinking we just talked about.
It elevates the human role from laborer to architect.
Exactly.
And this leads directly to the job security question. Is AI coming for your job? Gartner's perspective answers that so brilliantly.
Yeah, and urgently.
AI is probably not coming for your developer job.
But a developer using AI is probably coming for a developer who is not using it.
The threat isn't the technology. It's the competitive disadvantage of failing to adopt it.
Absolutely. In this landscape, if one developer can deliver high-quality, validated features at 5 times the speed of another, the slower developer, regardless of their skill, becomes a liability.
So the Renaissance developer has to embrace AI as an amplifier for their own human judgment.
And here's where the human cost of that speed comes in. Vogels coined a term for the core danger here, and it's the most critical warning in the whole keynote: verification debt.
We really need to dedicate time to this, because if you take one thing away from this deep dive, it should be how to avoid this debt.
Verification debt describes the massive and often invisible imbalance created when an AI generates code far faster than a human can possibly comprehend or validate it.
We went from writing hundreds of lines of code a day to generating thousands of lines in seconds.
So the bottleneck isn't production anymore. It's quality assurance, it's intellectual comprehension, it's human judgment. That time lag between code generation and human validation, that's the debt.
So what does this debt actually look like in a real production environment? It's not just messy code, right?
Oh, it's so much more insidious than messy code. The consequences are often invisible until disaster strikes.
For example,
Okay, first, security vulnerabilities. An AI agent trying to optimize for speed might use an outdated library with known vulnerabilities, or introduce subtle logic flaws that a quick human skim will miss.
right. Second,
Hidden cloud costs. AI agents can over-engineer solutions. You ask for a simple cache, and the AI generates some massively complex, multi-region, high-availability thing that consumes 10 times the compute you need.
And that turns into massive, hidden cloud bills that just accumulate every month.
And third, hallucinated APIs. Vogels specifically warned about this. An agent might hallucinate the existence of your internal company APIs, generating perfect-looking code that calls resources that just don't exist.
Which leads to runtime exceptions and these deep integration headaches.
Yeah.
So the code looks perfect, but it's calling a ghost.
Exactly. And a busy developer might just assume the function exists somewhere else and ship it. That's the debt. And it's incurred primarily through what he called vibe coding.
Vibe coding, I love that term.
It's the technical equivalent of gambling. You're just relying on vague natural language prompts, the vibe for quick code generation.
Like saying, hey, make a new checkout service that's really fast and secure.
That instruction has zero formal requirements. Vogel said, without attention to detail, vibe coding is just reckless.
Can you give us a concrete example, like a bad prompt versus a good formal specification so we can really internalize the difference?
Absolutely. A vibe coding prompt would be, make the search function faster and handle errors gracefully.
Useless.
Totally useless. The agent has no clear constraints. A responsible spec-driven prompt would be, develop a new real-time inventory search function.
Okay.
Requirement 1. Latency must be under 50 milliseconds for 99% of all queries from North America. Requirement 2. Use only approved AWS services from our governance catalog. Requirement 3. Error handling must include exponential backoff.
The structural difference is enormous. The vibe coder is asking for a wish, the Renaissance developer is providing a blueprint.
And the debt accumulates when you accept the wish fulfillment without checking the blueprint. If you're not specific, the AI makes assumptions. And those assumptions are almost always wrong in some subtle, costly way.
So if the AI is generating code at this velocity, the critical control point shifts from the keyboard to the point of integration.
Right.
What's the key mechanism Vogels stressed to apply that human judgment?
It's the code review. He stressed that human-to-human code reviews are now more critical than ever.
This isn't just a checkbox item anymore.
No, it serves 3 vital functions. First, verification, applying human judgment to the AI's logic. Second, knowledge transfer. Senior engineers are teaching junior engineers why the AI chose a particular path.
And third,
institutional memory. The code review makes sure that specialized business rules, things that are not in the foundational model's training data, are correctly applied.
so the code review isn't just about catching bugs. It's about making sure the craft of software development is still learned person to person, even when a machine is typing.
Which brings us to the evolution of the tools needed to fight this debt. We've moved from simple IDE plugins
Like Code Whisperer.
to more bespoke agents, and now we're entering the era of the fully agentic IDE.
Agentic IDEs are built around this idea of autonomous agent systems that can orchestrate, monitor, and verify the work of other agents.
It's not one big tool, it's a swarm of specialized microbots working under an AI manager. And this demands that new methodology, spec-driven development, or SDD,
The concrete countermeasure to verification debt.
because it elevates the human role to specifier and validator. It demands that developers use what they call communication with precision.
So before anything is coded, the human has to turn their intent into formal, unambiguous requirements.
And that rigor pays off.
Oh.
Internal studies Vogel cited showed that adopting SDD can reduce feature delivery time by nearly half.
That's a huge saving.
It is, because you avoid all those costly late-stage debugging cycles that come from unclear intent.
The specific tool that AWS introduced to enforce this is the new agentic IDE, Kiro. Let's walk through that workflow.
Kira's process is really structured to keep the human in the loop. Step 1 is requirement lock. The developer enters the precise, formal requirements,
The spec.
and it gets locked. Step 2. Kira's primary agent generates a technical design document, architecture diagrams, database schemas, APIs.
And step 3 is human validation.
The human developer must review and approve that technical design before any code gets written. That's the first critical control point.
And only after that, step 4, Kiro creates the executable tasks for its atomic agents.
The human is signing off on the design, not the final code itself. That's a massive shift in focus.
The developer moves from implementer to architect and quality controller.
And we have a phenomenal real-world example of this shift from Delta Airlines. They were early adopters.
Seeing, almost 10,000% growth in adoption of Amazon Q Developer.
That built the organizational trust. But the real capability shift happened when they piloted Kiro.
This is where it gets interesting.
The Delta case study is crucial because it shows the leap. They shifted from asking the AI, help me write this function, to demanding, help me build this feature.
Because Kiro could integrate Delta's specific non-public business rules and governance context.
Exactly. The institutional memory that AI didn't have. Kiro's ability to internalize rules like all flight changes must adhere to fare class X is what transforms it from a co-pilot into an autonomous partner.
And what's really fascinating is the unexpected benefit on the business side.
Yes.
They're non-coders, they're business product owners, were trained to use Kiro.
And this is where the emotional impact comes in. Imagine being a product owner whose idea usually disappears into a ticket for 3 months.
Right.
Now, these non-coders were able to generate working prototypes, not just mock-ups, functional code in days or weeks instead of waiting a whole quarter.
That just accelerates the feedback loop and validates concepts almost instantly. It removes all the friction from innovation.
To support this workflow, the underlying architecture has to evolve. Vogels emphasized we're moving from microservices toward a full agentic architecture.
Okay, we need to clarify the technical distinction there. For a lot of builders, microservices are still the pinnacle. How do atomic agents differ?
If we use an analogy, a microservice is like a department in a company. It's specialized, but it still handles a range of related tasks.
Like a user authentication service handles login, token management, password resets.
Right. It's loosely coupled, but still kind of complex inside. An atomic agent is a highly specialized robotic arm designed to do only one thing perfectly and independently.
So smaller, more granular.
Much smaller. Instead of a user auth service, you might have one atomic agent just for password hashing and comparison, another for token generation, and a third for session expiration.
So monolithic architectures get broken down into components even smaller than microservices.
And the complexity shifts from managing the internal logic of a service to managing the orchestration between hundreds of these tiny atomic agents.
Which is why you need an agentic IDE like Kiro to manage that for you.
And critical to that is model choice. You don't want to rely on one single AI brain. The use of Amazon Bedrock ensures developers have choice across multiple foundation models.
Titan, Anthropic Claude, Stability AI.
Vogels said it would be unwise to expect one model to do everything correctly. You have to select the right specialized model or atomic agent for the job.
Choice is key to resilience and efficiency.
Exactly.
Vogels' vision also extended way beyond the developer's terminal, touching on some major societal impacts.
Right.
Let's start with the future of learning.
AI is driving a revolutionary change in education. Tools like Khan Academy's Kamigo are providing personalized, one-on-one tutoring on a massive global scale.
Something that historically was a luxury only for the extremely wealthy.
Now, AI democratizes that. The teacher, freed from grading papers, can focus on creativity, mentorship, and the unique human needs of the students.
He also tackled a really complex global issue, the public health crisis of loneliness.
This is a profound area. The World Health Organization has designated loneliness as a genuine crisis, with risks comparable to smoking.
And we're talking about companion robotics, like Amazon Astro.
The goal isn't to replace human caregivers, but to augment them. These tools provide routine monitoring, safety checks, and basic, friendly interaction for the elderly and isolated.
Working with human caregivers.
Exactly, bridging the gap until human contact is available.
And finally, we have to address the challenge of cultural bias in AI.
A critical, technical, and sociological problem. The vast majority of Gen AI models were trained on Western English language data.
So the models absorb that dominant culture,
leading to outcomes that are often inappropriate or even harmful in non-Western contexts. He gave that example of a model prompted in Arabic about Islamic prayer.
a non-alcoholic context.
And it hallucinated a recommendation for an alcoholic beverage, a total failure of cultural context.
And the path forward.
It drives the urgent need for diverse, regionally focused models. Models trained on non-Western data, like J's for Arabic or Yi34B for Chinese. As developers, we have to choose the culturally appropriate model for the task.
So if we synthesize everything from this deep dive, the overriding takeaway is just the sheer, uncompromising acceleration of the toolchain.
The speed is staggering. Vogels mentioned that Kiro Powers, a major new feature suite, went from inception to production in under 4 weeks.
The velocity of innovation is not slowing down.
Not at all.
But speed isn't the ultimate measure of success. Vogel's famous mantra still rings true, maybe more urgently than ever. Everything fails, all the time.
AI speed doesn't negate the need for resilience. It just amplifies the consequences of failure.
So the new focus isn't just on writing features fast, It's on designing robust systems that tolerate failure, guided by disciplined human judgment.
That shift in mindset from laborer to architect and validator, that is the definition of the Renaissance developer.
Which brings us to the final, provocative thought that Vogels' keynote leaves us with. The architectural shift is moving past microservices to a full agentic architecture.
Right.
So you, the builder, you have to ask this fundamental question about your current applications. How can I re-architect my system, not as a collection of functions or services, but as a combination of independent, specialized atomic agents?
That is the future of resilient system architecture. And that's the challenge that will define the next decade of software development.
That's a powerful challenge to end on. Thank you for joining this deep dive on the future of building. This has been Le Podcast de Philippe.
And if you found this information valuable and want to keep evolving as a builder, please help us grow.
Share this podcast and help us reach 2,000 subscribers. Your support is what makes this deep dive research possible.